Can you hear me?
Yes.
Yes.
Okay.
Yes, sir.
For this example, it need to write the Z matrix. The Z matrix means we could add branch impedance matrix Z, and Z used to express the VCR function U equal to Z mod I plus IS minus US. This is a Z matrix. For this set, we have 1, 2, 3, 4, 5, 6 branches. This set has 6 branches, and the branch 2, branch 3 have mutual inductance. So this position will be J omega m or minus J omega m. It will be positive or negative depending on the direction definition. Because this set don't define the direction, so it may be positive or may be negative. This 2 and 3. For the branch 1 have only one resistor, R1. Branch 2, 3, this part. Branch 4, J omega C, 1 over J omega C. For the branch 5, only one resistor. For the branch 6, this branch 6, pay attention, this branch 6, we draw it again. R6 mu U4. So this will be U6, total U6. This will be I6. The U6 will equal to the IR6 mod I6 plus mu U4. U4 is this position equal to R6 I6 plus mu J omega C, 1 over J omega C, I4. So for the U4 will be mu. U4 will be this part plus this part. And when we write to the matrix form, this Z mod I. So this position is a column 4. This position will mark the I4. This position will mark the I6. So this example, try to express the branch contains the independent source. There will be some components in the non-diagonal position. This position. Pay attention. This position is branch 6. The row 6, but it is affected by the branch 4. So it will be column 4. Column 4 position will have component. Because it means the branch 6 affected by branch 4. So it will be row 6, column 4. Column 4 have components, have elements. Okay, we have introduced the VCR. Now we introduce the KCL. Use the loop matrix B. This KCL. Use IL to express IB. IL is the loop current. And this VCR branch function. UB equal to ZIB plus ZIS minus US. B UB equal to 0. So means B, this part, B mod this part equal to 0. B multiple this part equals 0, and we use the use this part to express IB. We can go to the function BGBT IL equal to BUS minus BGIS. For this function, only IL, that means the loop count I, is a variable. This is a variable. And US, IS is a source. The source. B transform. B is a matrix, loop matrix. The J is a branch. The branch impedance matrix. So this is the loop canonical method of matrix form. Loop canonical method matrix form. This is matrix form. We define GL. This is GL. Define GL equal to BJB transform. This is GL. Its loop impedance matrix. Its diagonal element is the loop self-impedance. Other element is the mutual impedance between two loops. We define the ULS. This part is ULS. We define as a loop voltage source vector. So we can write this function as GLIL equal to ULS. IL is the loop current. GL is the loop impedance matrix. ULS is the loop voltage source vector. This loop current matrix function. The steps for loop method matrix form. At first, from the toplet, we should write the B, Z, S, US. And then find the GL, UL, and then get the function. Get the function, find the IL, the loop current. And from KCL, we can from the loop current get the IB, the branch current. And then from the VCR, from IB, we can calculate UB. For example, use matrix method to solve this problem. Loop matrix method. Draw diagram at first. And we use a 1, 2, 5, 1, 5, 2 at first, at tree. So 3, 4 is core tree. 1, 2, 3, 4, 5. Loop 1, loop 2. Draw matrix B at first. And write the Z, the branch impedance matrix. For this circuit, we have no mutual inductance, no independent source. So the matrix Z is a diagonal matrix. US is a voltage source. IS is a current source. Pay attention. This position is negative. Y is negative. Let's come back. For branch 2. This branch 2. We define from up to down. This branch 2. But for the branch 2, the source the US is positive is from up, negative is down also. This is not the same as we have defined. We define the basic, the standard form. This is a standard branch UK left is positive, right is negative, but the USK should be left is negative, right is positive. For this definition, it should be positive. But if this branch is not at this definition, so the US we should write as a negative. This Y is negative. But for the IS is positive. Let's go back. For the IS, we can find the branch 1 from up to down, but the IS from down to up. According to our definition, the branch count from left to right, the current source from right to left is positive. So this branch direction is the same as the definition. So this current source is positive, but this voltage source is negative. This is the reason. It's why it's negative and positive. Pay attention for this problem. The loop current match function like this. This function. We have, pay attention, we have several steps. Step 1. Draw the diagram. Step 2. Write the matrix B, matrix C, and US and IS as C, US, S, and B. And step 3. Draw the function B, C, B. Transform L equal to BUS minus BCS. So for this kind of question, this kind of problem, we have 3 steps. And the step 1, always finished by teachers. You only need to step 2 and step 3. For the calculation, step 4. Actually, we don't need you calculate it because we always use computer. It's designed for computer. This method designed for computer. So we don't need you to calculate this matrix. This matrix calculated by computer. We don't need you to calculate by hand. We just need you to write the step 2 and step 3. This is important for you. This is for you important. The next method, the node voltage matrix method. At first, we introduce the branch admittance matrix. We have introduced a branch impedance matrix. If there's no dependent source and no mutual inductance, we can use the current to express the voltage. So it will be Zk. We can inverse this function. We can use voltage to express current. Ik is here. Ik equal to Yk Uk minus Yk Usk. This means Iek, this current. This current is the total Uk plus Usk. Uk plus Usk is this position voltage. This voltage. This voltage is Uk plus Usk. This Uk, this Usk. And so this current Iek is Zk, it's Yk multiplied Yk. Will be this current. So this part is for this Iek minus Isk minus this current source will be the Ik. So this function is use voltage uk to express ik. This function is used ik to express uk. Ik express uk. When we run this function in matrix form, this matrix form, every branch, branch source, branch current source express branch current. This matrix form vector form. For the matrix y, the matrix y will equal to the matrix Z inverse. Matrix Z inverse. It will be matrix B multiple B matrix. If the circuit have mutual inductance, for example, branch 1, branch 2 have mutual inductance, we have calculated the branch impedance matrix as this form. For the branch, we calculate Z at the first. For the matrix Y, we can calculate matrix Y equal to Z inverse. So for the case 2, the mutual inductance, we calculate the matrix B at the first, the matrix Z at the first, and then go to the matrix Y. Matrix Y for this part. This function to calculate the inverse of this part, inverse of the 2 multiple 2 matrix. Case 3. If the dependent source in the circuit, for example, if the source is a voltage control current source, assume IDK equal to GKJ UEJ. This KJ means the branch J control this branch K. IEK, this branch current. IDK, this branch current. Total IK, this branch current. This current will be 3 current altogether. IEK plus IDK. This IEK. This IDK. This RSK, 3 branch, the total branch current. This voltage control current source. If the current control current source, assume IDK equal to beta Kj IEJ. This means the J branch current controls the K branch current. The total current. IK is this IEK. This IDK, we should express this IEJ by YJ, UJ plus USJ. So this part is the IEJ. This part, beta Kj, IEJ. For the total B branch, if the branch J control branch K, so from the row K, column J, there will be a component here. It's GKJ. If this form, it will be the beta Kj, YJ in this position. This position is only the GKJ. Okay, we have introduced how to use the voltage. The voltage to express I current is a YK express. Now we introduce node voltage matrix form. The branch we shall use U to express I. The K cell AI equal to 0. The K will, so AI equal to 0, sorry, this should be I. This I. Branch current, branch voltage source, current source. AI equal to 0, so AYU plus AYUS minus S equal to 0. And for the KY function, we call the U, this U equal to A transform UN. So we can get a function A transform UN equal to AIS minus AYUS. We define this as ISN. And define the first part A transform as a YN. We call it as a node admittance. The right side node current. So total function write as YN UN equal to ISN. The steps for the node voltage method. Step 1, draw diagram. For example, for this circuit. Node 4, 1, 2, 3. We choose node 4 as reference. Write matrix A. 4 is reference. Write A at first, and then write the matrix Y. Because this circuit has no dependent source and no mutual inductance, so it will be a mutual matrix. This 0, 0. And then write the USIS. Pay attention to the USIS. For the US, there will be negative. The IS, one is negative, one is positive. Y is negative and positive. I have introduced to you before. You should compare the branch. For this branch, compare the branch with the definition of the basic standard branch. And then write this function. If we calculate the function, we can get the AYA transform. This is YN, this this UN, this ISN, this ISN. So for this function, this is the node voltage method. Node voltage method matrix form. Node voltage method matrix form. We have introduced the loop current. Loop current matrix form. Its function will be very similar to this function. Is B transform I L N equal to B U S minus B C I S. It's very similar. For these two methods, there are 4 steps also 4 steps. Step 1, draw diagram. Step 2, write the B, C, U, S, I, S, or write the A, Y, U, S, I, S. So step 3, write the function, these two functions. function. Step 4, calculation. The calculation is calculated by the computer, so we always care about step 1, step 2, and step 3, because for step 1, the teacher will always draw a diagram for you, so you need only care about the step 2 and step 3. For the second question, there are mutual inductance between current, the loop 1, the branch 1 and branch 2. Draw diagram at first, and write the A matrix. And I is 0. The only branch 5 have current source. The US will be 0. US will be 0. US 0, and then write Y, B, Y, matrix Y. For the matrix Y, the branch 1 and branch 2 have mutual inductance. So we should calculate the Z at first. Z equal to the J omega L1, J omega L2. For the branch 1, branch 2 mutual inductance, it should be J omega M, J omega M. So all are positive. And then inverse. So this part is this Z matrix inverse. For the branch 3, there's a current source. Branch 3, current source. UA is branch 4 voltage. 24 volts. So the branch 3, we can draw it again. It will be like this. So this is I3. This is GUA. So the total I3 equal to the U3 mod J omega 3 and minus GUA. UA is U4. UA is a U4. But this means GU4. So this position is minus G here. This position is J omega C3. Pay attention to this position. This branch 4 affect branch 3. So it will be on the row 3, column 4. And then write the function at the last. Then we finish all this question. Okay, today is enough. Let's make a conclusion. For today's class, we have introduced A, B, Q matrix at first, and then introduce A, B, Q to express KVL. And then we introduce how to express VCR. We define the standard branch at first. And then for the standard branch, we try to use the current express voltage. We define the ZB. If we use the voltage to express current, we define the YB. And then we introduce the loop calendar method. And the node watch method. The method match for. The match form, we get two functions at last. B, G, B transform IL equal to BUS minus B, G, IS. For the AYA transform UT, UN equal to AIS minus AYUS. To write these two functions, we need to write the B, G, IS, US for the A, Y, US, IS. Okay, today is enough. Today's class is over. Today's class is over. If you have any question, you can type in the Tencent meeting. If any question, you can type in the Tencent meeting. If there's no question, I will close the PowerPoint. Can we get a recording of lectures? Everybody, you can record it yourself. You can record it yourself, and I'm recording it also. So you can get the recording from your classmates, and I will upload the recordings to the Google Cloud later. Okay, no problem. See you.